All right, so again, this is the polynomial section 1.4 in our book, part 2. So we were on the grouping method. So last time we were doing factoring. Factoring basically ax squared plus bx plus c equals 0. We had the easy case, which basically just looked like x squared plus bx plus c equals 0. So, let me come up with a couple of examples real quick. Let's say solve a, maybe we have x squared minus 17x plus 72 equals 0. So you need two numbers that multiply to positive 72 but add up to negative 17. So that's how you know they both have to be negative. To multiply to a positive number and add to a negative, they both have to be negative. The only way you multiply to a positive is either they're both positive or both negative. So negative 8 and negative 9 do the trick. In this case, that just takes you right to the factorization. And then remember to solve it. It's essentially the numbers you would plug in for x that would make the factor 0. So your two answers would be x equals 8 or x equals 9, right? Because 8 minus 8 is 0, and 9 minus 9 is 0. So let's do one more of this type. Let's say x squared O plus 10x plus 25 equals 0. So in this case, you want two numbers that multiply to 25 but add up to 10. So that's just 5 and 5. So this would factor into x plus 5 times x plus 5. So we get a repeated factor. That's the same as x plus 5 quantity squared. Now, since they both match, we only actually have one solution here. So x equals negative 5 is the solution to that problem. So then we also have the harder case where a is not 1. So it doesn't just start off with x squared. So let's do an example. Remember what we use here in this case, we use the grouping method. So we have to decompose the middle factor, and then from there, we want to factor out the GCF. So let's say, again, we just want to solve. So A, we have, say, 6x squared minus 13x minus 5 equals 0. So with the grouping method, you don't just look at the last number. You have to multiply the first number with the last number. So we have to multiply 6 by negative 5. So 6 times negative 5 is negative 30. And you need two numbers that multiply to negative 30 but add to negative 13. So let's say negative 15 and positive 2. So we're going to rewrite 13x as minus 15x plus 2x. So this is 6x squared minus 15x plus 2x minus 5. Excuse me. So what happens is we look at this first group and then the second group. So the first group, you can take out a 3x, leaving us with 2x minus 5. So two things you'll notice. The second group is already 2x minus 5, And 2x minus 5 has a GCF of 1, right? There's nothing you can pull out. They don't have any common factors of x or numbers that divide both integers. So what we can do is we can just write a 1 in front and then put that in parentheses as well. And now the parenthetical quantity, 2x minus 5, we can pull out. So we get the numbers in front as one factor, 3x plus 1, and 2x minus 5 as the other number. And again, you would set each of these separate linear factors to 0 and solve. So if you solve 3x plus 1 equals 0, you get x equals negative 1/3. And if you set the second one equal to 0, you would add 5 and divide by 2. So you would get x equals 5/2. So these are your solutions. Okay, one more example from factoring before we do the quadratic formula. Let me try and leave a bit more of that on though. So let's say we have 7x squared plus 16x plus 4 equals 0. So again, multiply the first coefficient with the last coefficient. 7 times 4 gives you 28. And we want factors that would add to 16. So let's do 14 and 2. So we have 7x squared plus 14x plus 2x plus 4 equals 0. And then again, separate into two groups. So 7x squared plus 4x, we can take out a 7x. And that would leave us with x plus 2. And 2x plus 4 has a common factor of 2. So you can take out a 2 and get x plus 2. So then your two factors are going to be 7x plus 2 times x plus 2. So this gives either x is negative 2/7 or x is negative 2. So do we have any questions on factoring, either the shortcut or by grouping? This is kind of just supposed to be a refresher. But if you do have some trouble, please let me know.
Yeah, so I had a question. So you went from 7x x plus 2 plus 2x plus 2 equals to 0 to 7x plus 2 to x plus 2. How did you like?
Okay, so do you notice that the parentheses here matches perfectly?
Mm-hmm.
So let's imagine we had 7x times capital A plus 2 times capital A. Then you could take out the capital A, right?
Yeah.
And you would have what on the inside?
2.
7x plus 2. Because remember, the distributive law goes both ways.
Mm-hmm.
You could either have A times B plus C, which is AB plus AC, or you could do it on the other side, say B plus C times A, and you would get, AB plus AC again. You could have the A on either side. So do you see how I'm factoring this A out?
Yes.
So do you see how really this x plus 2 is really acting like the capital A?
Mm-hmm.
Right?
Okay.
So
Thank
this
you.
line is supposed to look like this line. So just think of capital A as x plus 2. Right? Capital A is just basically standing for an algebraic expression that matches. That's a good question, and something that certainly stumps a lot of students. I mean, you can kind of go through it not understanding and just realize you put those numbers into the parentheses and you'll get the right answer, but it really is working because we're using the distributive law in the other
Okay,
direction.
so think about the previous question then. Can we go to back to A with the same step?
Yeah, it's the same step, right? Because our capital A, what would it be? It would be this 2x minus 5. Right? I'm taking capital A out, so capital A is right here. The 3x comes out and the 1 comes out. It's exactly the same.
I'm put like, oh, the 1. Okay. I understand. Thank you.
Yeah. Okay, so if not, we'll move on to the quadratic formula. So I'm just going to require that you're able to use it. We're not going to go through the derivation. But basically, if you perform this completing the square idea, which we're not really going to go into, but if you do completing the square on ax squared plus bx plus c equals 0, you get something called the quadratic formula. So you can plug these things in, but it will give you the answer to an equation, that has these coefficients. But factoring is still an important technique that comes up in other areas. So it's important that you know how to factor, even if you say, okay, any quadratic equation with known coefficients can be solved by the quadratic formula. Don't disregard the steps of factoring because they're prevalent. They come up again and again in a variety of different places. Okay, so let's do the third technique. So remember, the third technique is the quadratic formula. The first we did was completing the square. The second was factoring. We're now on the quadratic formula. So what does the quadratic formula say? It says the solutions to the equation ax squared plus bx plus c equals 0 are. So it's important before you start identifying anything that your quadratic equation is written in this form. You have to have 0 on one side and everything else on the other side. Otherwise, your coefficients will be messed up. Okay, so this is x equals minus b plus or minus the square root of b squared minus 4ac, with everything being divided by 2a. Okay, so that's the formula. One important thing to note, or a term, the stuff underneath the square root, that b squared minus 4ac quantity is called the discriminant. Okay, it's important because it'll tell us how many solutions we have. In terms of real numbers, there's 3 possibilities. So if your b squared minus 4ac is greater than 0, then what happens is we have 2 real solutions. If it is equal to 0, you have exactly 1 real solution. And the third option is it can be negative, in which case we'll have no real solutions. You would have some complex solutions, but again, we're not really dealing with complex numbers in this class. So we have b squared minus 4ac less than 0. So this is 0 real solutions. And if you're let's say a graphical person, you think about graphs first. Anytime you're solving a quadratic equation, what you're really doing is graphing the parabola and then seeing where it hits the x-axis. So these graphs corresponds to kind of 3 possible pictures. If you have 2 real solutions, a parabola could hit the x-axis 2 times, right? So that would be an example where you'd have 2 real solutions. If you would have 1 real solution, how is that possible? Well, that would mean maybe your parabola touches the graph at just the one place and is tangent there. So that would be 1 real solution. And then 0 real solutions, it just might not hit the x-axis ever. Your parabola could certainly be completely above the x-axis and never intersect it. So you have different pictures. So you have 2 intersections, 1 intersections, or no intersections possible. So that's kind of the pictorial analog to what you're gleaning from the discriminant and the quadratic formula there. So let's solve a couple by the quadratic formula. Again, it's a little bit boring, but you need to make sure that you don't mess up the arithmetic. So solve by the quadratic formula. So x squared minus 10x minus 1 equals 0. So again, I'm just going to identify. Notice everything's on the one side, the left-hand side, and you have 0 on the other side of the equation. So what I'm going to do is identify the 3 coefficients, a, b, and c. So in this case, a is equal to 1, b is equal to minus 10, and c is equal to minus 1. So let me just write down the formula one more time since it's not on the board, or it's not in the same picture, so you can see how this goes. Again, we're just saying, okay, x is negative b plus or minus the square root of b squared minus 4ac, with everything being divided by 2a. So when we're simplifying, we get x equals, well, b is negative 10, so negative b is minus negative 10. So that's going to become positive 10. Then we get plus or minus the square root of... So I will say this is one area where people often make a mistake. B squared, you have to put that negative 10 in parentheses. If you don't, so here's kind of like a warning. Negative 10 squared is not the same thing as negative 10 squared, right? This one is actually equal to negative 100, whereas this one is equal to positive 100. So if you forget the parentheses, you're going to be off by quite a bit in your answer. So we have that b squared minus 4 times our a times our c, which is negative 1, with everyone being divided by 2 times 1. And then we just use arithmetic to simplify. So we'll get x is equal to 10 plus or minus the square root of 104 over 2. And then remember, really, this is 2 answers, right? So you could have maybe... A lot of times they'll denote them x1, the smaller one, 10 minus square root of 104 over 2, which approximately is about negative 0.10. Or the second solution, 10 plus the square root of 104 over 2, which is, about 0.1. Again, there's lots of solvers you can look up online to do this sort of stuff for you, but when you practice it, it makes sure that you're reinforcing some of the order of operations you may have forgotten, like the warning right there. If you forget parentheses, that can cause a real big problem. And just because you type it in the calculator doesn't mean it's not going to come out perfectly. So let me see here. Okay. Let me give you a couple to practice. Were there any questions on that one? Let me just give, so we'll not do breakout sessions for this one. I'll just give you two problems, a factoring by grouping problem and a quadratic formula problem. And then I'll give you 5 minutes or 6 minutes or something like that. And then we'll go ahead and work on them, work them out together. And if you have a question, you can just raise your hand, and I think I can. Well, I don't know. I was having problems with the breakout session this morning. It kept crashing, so I just don't want to do it again and have everything mess up. So let's say we have 8x squared minus 19x minus 15 equals 0. So you should be able to factor that one. And let's say B, solve by quadratic formula. Say 3x squared minus 5x plus 1 equals 0. So this should work. So like I said, I'll give you 5 minutes to work on those two, and then we'll come back and do them together. All right, so hopefully you've written the problems down. I'm just going to navigate back to the WebEx screen in case anyone raises their hand or asks a question. Okay. Okay, give you one more minute, and then we'll go ahead and go through both of these. All right. So let's go ahead and start with A. Keep it on the screen. So for A, we wanted to multiply the first by the last. So 8 times negative 15 is minus 120. And oftentimes the hardest part is figuring out the numbers. So the ones that ended up working were minus 24 and positive 5. So if your number is negative 120, we know one of them has to be positive and one of them has to be. So those ended up working. So now we rewrite it as 8x squared minus 24x plus 5x minus 15. So then we have the two groups, 8x squared and 24x have a greatest common factor of 8x. So we can take out the 8x and we get x minus 3. And from 5x minus 15, we can take out a 5. And we also get x minus 3. So we have our two factors now, 8x plus 5 times x minus 3. And those will lead to solutions of x equals minus 5 over 8 or x equals 3. Any questions there?
For that one, can you use, or actually you want to use it by factoring, right? Because I solved it using the quadratic formula.
Yeah, you can, but if I specify by factoring, you should do factoring. I mean,
Okay.
factoring comes up later in other things. So I made that comment earlier, like you can solve all of these by the quadratic formula, but you're still going to need factoring later.
Okay.
So if you don't practice it, it might come back to haunt you. Of course, if it's just a numerical answer on the homework, of course you can use the quadratic formula. No one's going to be able to stop you. But there's a number of problems that can't be done using the quadratic formula. I mean, I can show you one in a second, but I just want to go through these. All right, so let's go through the quadratic formula on B. So for B, let's just again note what our things are. A is equal to 3, B is equal to minus 5, and C is equal to 1. And that's all we really need to know before applying the quadratic formula. So we end up with x equals the opposite of minus 5 plus or minus the square root of, remember the parentheses, minus 5 squared minus 4 times 3 times 1, with everyone being divided by 2 times 3. So we get x equals 5 plus or minus the square root of, looks like 25 minus 12. So that's going to be 5 plus or minus the square root of 13 over 6. And you could get your two approximations if you want. Let's say x1 is approximately 4, x2. So we get about 0.23 or 1.43. Those would be the two solutions. It really depends on the form. If they ask for an exact answer, you'd want to use the one with the square root of 13 still, the second to last line. If they ask for a decimal approximation, it just depends on how many decimal places they specify. So that's pretty much it for quadratics. For general polynomial functions, let's talk about two things. Let's talk about their end behavior and intermediate behavior. And then that'll do it for polynomial functions. So, right, remember in general, a polynomial can have higher degree than 2. But the techniques for solving the equations, they're not so easy to do by hand past the quadratic formula. That's pretty much the limit of what we're memorizing for formulas. There are formulas for degree 3 and 4, but 5 and higher cannot be done with just addition, subtraction, multiplication, division, and radicals. Anyhow, so let's say graphing general polynomials, or higher order, higher degree polynomials. So basically, we need to understand the end behavior. Well, let's say two things. One, the end behavior, and two, the intermediate behavior. So let's have a look. Sorry, I'm trying to keep that on the screen if you're writing. So the first thing, the end behavior. So what are we trying to graph again? What does it look like? So let's say given f of x is some polynomial a sub n x to the n plus a bunch of other guys plus maybe like a1x plus a0, something like that. The end behavior is completely determined by looking at this first term. So completely determined by the leading term. So what are the two things that are important? So one is a sub n positive or negative, and two is the exponent n even or odd. So once you answer those two questions, you know the end behavior, meaning where the arrows go as you go out towards the edges. As you go really far left or really far right, are we moving upwards or downwards? So there's four possibilities. Right? It's because there's two possibilities for the first case, a sub n, and two possibilities for the second case. So there's four possible ways, right? You could have a n positive and even or n odd. That's two of them. Or you could have a n negative and even or n odd. Those are the other two. So basically, the first case, let's say, again, a n is positive and n is even. Now, we don't know about the intermediate behavior, so we don't really know, what's happening in the middle. There could be all sorts of stuff, but basically, eventually, both sides are going to rise. You might have all kinds of funny behavior, but basically, the arrows say both sides rise in this case. The second case, let's say a sub n is positive and n is odd. In this case, we have the left side falls and the right side rises. Okay, so those are two of the possible graphs. Just if you want some basic examples of these, you could have, for this one, just something like y equals x squared. And for this one, maybe y equals x cubed. Just a single term polynomial, very basic. So the third and fourth case are going to involve a sub n being negative. So let's say a sub n is negative and n is even. Well, in this case, you get both sides falling. So an example here might be y equals minus 5x squared, right? Notice the number in front is negative and the power is even. And then the last case, a sub n is negative and n is odd. So we get something like this. So left rises and the right falls. Excuse me. So maybe we have y equals minus 4x to the 5th power, right? Your number in front is negative and your exponent is odd. That's what we're looking at here. So that's the end behavior. Basically, you just kind of have to understand that there's 4 possible cases. You just look at the first term and then it breaks down into one of those. So I'll talk about the intermediate behavior and then hopefully we'll have time for an example. If we don't, then we'll start next time with an example or two of graphing these things. Again, this is kind of big picture. You know, the thing is, in order to get the intermediate behavior, we have to be able to factor the polynomial, and that's not always an easy thing to do, especially when the degree gets higher. So we have our intermediate behavior. So this basically talks about what happens at the x-intercepts. So this is what happens at the x-intercepts. So we'll say, suppose we are able to factor our polynomial and all of its roots is a fully factored polynomial. Then the multiplicity. So that's just a fancy word for the power of the factor. Determines what happens there. So there's just two cases here, whether the multiplicity is odd or the multiplicity is even. So if the multiplicity is odd, then we cross the x-axis. And 2, if the multiplicity is even, I'm going to say we bounce off the x-axis. Basically, we touch the x-axis and turn around. So bounce off the x-axis. Okay, so I know this is a lot of information very fast, and probably this is stuff that you weren't as confident on from your previous pre-calculus or college algebra course. I'm just going to show you how it works from graphing it through an example or two. This isn't the most important material in the world. I'd much rather you understand how to factor. I mean, this is important, but you know, there's a lot of graphing tools, and this is not something that we're building on as much. But it's certainly useful. I'm just trying to say for the purposes of our course moving forward. Let's look at how we can put end behavior and intermediate behavior together to graph a polynomial of higher degree. Let me check the chat, see if there's any comments. Homework 2 is due January 29th, and homework. Yeah. I'm gonna push back homework 3. I just wanted to make the first 3 homeworks available. I don't have the exact dates in my head. The problem is I copied my assignments from the summer session, and the summer session was an 8-week session. So they were doing homework every single week. So I need to adjust the dates. So I'm not exactly sure. But homework 3 will get pushed back. It's probably not going to be due on February 2nd. It'll probably be due later. I just haven't posted right now. So don't worry about homework 3 quite yet. Okay, so let's just try and do one example. So basically, let's say graph f of x equals minus 5 times x plus 2 cubed times x minus 4 squared. Okay, so first let's do the end behavior. So the end behavior we need to understand, so the number in front is -5. If you multiplied everything out, you'd have some x term. My question is, what is the degree of this polynomial? If you look at this right here, I'm going to give you 2 options. So just type your answer in chat, which you think it will be. Is the degree of this polynomial, f of x, is it 3 or is it 5? It's one of those 2 choices. So in the chat, just type either 3 or 5 based on what you think the degree of the polynomial is. Remember, the degree of the polynomial is what you would get if you multiplied everything completely out. So 3 or 5. Okay, a lot of 3s. I see 1, 5. So that's a good question. What's the difference between degree and multiplicity? So degree would be the highest power of x if you multiplied everything out. Multiplicity, the multiplicity of the x plus 2 factor is 3, and the multiplicity of the x minus 4 factor is 2. That's the difference. So multiplicity applies to a specific root, whereas degree applies to just the highest power you would see if everything were completely expanded. Any more guesses? 3 or 5? Okay, the answer is actually 5. And remember, so the leading coefficient here is -5, and the degree is actually 5. So why? Well, imagine if you had -5. This is a degree 3 polynomial if you expand it, and this is a degree 2 polynomial. So if you had -5 times x to the third times x squared, this would actually be -5x to the fifth. Right? The biggest thing you get when you expand x plus 2 cubed is an x cubed term. And the biggest thing you get when you expand x minus 4 is an x squared term. And then when you multiply them, the biggest degree from all of those would be the x to the third times the x squared. And in that case, you add those two exponents. So if you add together the multiplicities, you will get the degree of the polynomial. So basically add the multiplicities. If that makes sense. So that's the end. So what is the end behavior here? The end behavior, we have negative and odd. So for negative and odd, we had the left rises and right falls. Now for the intermediate behavior. We'll just make a little chart here. We have the intercept, the multiplicity, and then the behavior. So we have two intercepts from the factors, right? X plus 2 has an intercept of x equals -2. And x minus 4 has an intercept of x equals 4. Because -2 plus 2 is 0, and 4 minus 4 is 0. So the multiplicity of each one is the power of that factor. So the multiplicity of -2 is that power that's with it, 3. And the multiplicity of 4 is the power that's with it, which is 2. Now the behavior, remember, it crosses if the multiplicity is odd, and it bounces if it's even. So we see that it crosses here and bounces here. Okay, so now we can make the graph with all this information put together. So let me just do that real quick. I know we're just about out of time. And again, this is not super specific, but we have our two intercepts, -2 and 4. We know the left rises, so the left of that farthest dot has to go up, and right of that dot has to go down because the right falls. So I come to this dot, I cross, I approach this dot here, and I bounce, and then I connect to the other arrow. So that's a quick sketch of the graph using the end behavior and the intermediate behavior. So that will conclude the lecture for today. Any questions? Let's stop the recording.